What's going on, guys? Let's look at this problem right here. Here this question is asking, assuming that the op-amp in the circuit shown is ideal, VO is given by what? So here the question is asking for the V output voltage. First of all, we have to know the characteristics of an ideal op-amp, because in the question they have mentioned this is an ideal op-amp. Okay, for an ideal op-amp, the voltage gain AV is given by infinity, and this is also equal to VO divided by V input difference. And if we rearrange this one, V input difference is going to be equivalent to VO divided by infinity. That's going to give us 0. And V input difference also can be written as V plus minus V minus, voltage across the positive terminal minus voltage across the negative terminal. Since this is equal to 0, we can say V plus is equal to V minus. So this is the derivation we can derive for an ideal op amplifier. This is popularly known as virtual short. So this is called virtual short. Now let's see how it's going to help us to find out VO. Now see here, in the voltage across the positive terminal is V2, and we found out for an ideal op amp, voltage across the positive terminal is equal to voltage across the negative terminal. Since this is V2, voltage across the negative terminal also going to be V2. So in this node we are going to have V2. Now that's going to help us to find out VO, because we can apply KCL at this negative terminal at this point, at this node right here, and find out what is VO is equal to. Now let's go ahead and apply KCL at this point. KCL says addition of all the current entering the node, entering and exiting the node should be equal to 0. So KCL at V2 inverting terminal. Okay, inverting means negative terminal. So since we are looking at the V2 at the inverting terminal, that's why KCL at V2 inverting terminal. So this is the point we are applying KCL. Okay, now let's see what we get from that. What is the current? This is going to be V2 minus V1 divided by R. V2 minus V1 divided by R. And then from ground to here, this is going to be V2 minus 0 divided by 2R. So plus V2 minus 0, we can just leave it as V2 divided by 2R. And then V2 minus VO divided by 3R. The resistance in between is 3R. That is equal to 0. That's KCL. Okay, now let's try to simplify this one. It's better to write this one separately, like V2 over R minus V1 over R plus V2 over 2R, and here we can write this one as V2 over 3R minus VO over 3R. That's equal to 0. And if we move this VO to this side, because we are interested in finding what is the VO expression is, VO is going to be equal, VO over 3R is going to be equivalent to, also we can take all the V2 common, so this V minus V1 over R will be left alone. So this is going to be V, if we take V2 common, this is going to be 1 over R, and here we have plus 1 over 2R plus 1 over 3R, and we have this minus V1 over R left alone, so this is going to be minus V1 over R. And if we simplify this one, let's see, we can also move this 3R to this side. In that way we will derive this one as, also we can simplify these R's, and finally if you multiply this 3R to that side and simplify this one, you will get 11 over 2V2 minus 3V1. So VO, this is equal to VO, and VO can be written as minus 3V1 plus 11 over 2 V2, and this is going to be the final expression. This is going to be the V output voltage in terms of V1 and V2. I hope this helps. Thanks for watching.